asked me. Some people were already aware about a merge sort although, but still they didn't ask. The scenario is, why on earth you would always want to divide your array into two parts? Why I am not doing merge sort by dividing my array into three parts? Why I am not doing division into four parts, five parts, and so on? So when I was working at Interview Bit, I was in the interview panel. We used to ask this question a lot to the interviewee, that merge sort as an algorithm asks you to divide your array into two parts. Why not three? Why not four? Why not five? Why not something else? Why only two? Anyone? Why only two? Makes easy? No. That's the worst argument that you can give. Programmers doesn't look for easier things initially. जिसने इतना सोच लिया भाई, जिस साइंटिस्ट ने इतना सोचा होगा, वो इजी के पीछे तो नहीं जा रहा होगा. ऐसा ही मानिए. स्पेस नो. इवनली ब्रेक नो. क्यों 3 में अगर डिवाइड करूंगा तो इवनली ब्रेक नहीं होगा. 3 के फैक्टर में इवनली ब्रेक होने लग जाएगा. 2 से कैलकुलेशन सही रहती है. अरे मैथमेटिशियन के लेवल पे जाके सोचूंगा. मानो तुम सब मैथमेटिशियन हो, तो कैलकुलेशन इजी तुम्हारा करना तुम्हारा एजेंडा नहीं है. तुम कोई भी कैलकुलेशन सॉल्व कर सकते हो. ठीक है, तुम हो मैथमेटिशियन प्रो मैक्स, अल्ट्रा प्रो मैक्स, एबीसीडी. तुम कैलकुलेशन की इजीनेस तुम्हारे लिए फैक्टर नहीं है. ठीक है, हार्ड टू कैलकुलेट अभी बोला ना, तो मैथमेटिशियन हो, तुम्हारे लिए कुछ हार्ड नहीं है. एवरीथिंग इज अचीवेबल फॉर यू गाइस. कोई भी कैलकुलेशन होगी तुम उसको कर लोगे. कॉल्स कम करेंगे, कॉल कम करेंगे. अच्छा, कितनी कम हो जाएगी कॉल? कितनी कम होगी या कितनी बढ़ेगी कॉल? अच्छा चलो देखते हैं. अगर मान लो तुम n को 3 एरेज ऑफ n by 3 में डिवाइड करो, फिर इसको 3 एरेज ऑफ n by 9, 3 एरेज ऑफ n by 9, 3 एरेज ऑफ n by 9 में डिवाइड करो, तो फाइनल लेवल पे क्या होगा? n by 3 रेज टू द पावर क्या आ रहा होगा? n by 3 रेज टू द पावर क्या आ रहा होगा? which will be equal to 1. n is equals to 3 raised to the power k. Take log base 3 both sides. Take log base 3 both sides. So log n base 3 is equals to log 3 raised to the power k base 3. K is equals to log n base 3. Can I say that? तो यहाँ पे हमारे नंबर ऑफ लेवल्स कितने आ रहे हैं? हाउ मेनी लेवल्स आर वी गेटिंग? log n base 3. And I believe everybody knows that log n base 3 is less than log n base 2. ये बात तो सबको पता ही होगी. log n base 3 is less than log n base 2. चेक करें. log base calculator. log base 3, if I do 1 2 3 4 5 6, calculate, we are getting 12.57. And if I do log base 2, we are getting 19. So can I say log base 3 is less than log base 2? Yes or no? See yourself. मतलब मैं नहीं बोल रहा हूँ, खुद ही देख लो. Divide and conquer algorithm, that's why 2 parts. Wrong answer. Think about it guys. So मेरा आंसर करेक्ट था. 1 सेकंड. श्रेय नो. स्पेस कॉम्प्लेक्सिटी के कॉरेस्पॉन्डिंग जो तुम कह रहे हो तो सही नहीं है. एक और बहुत बड़ा प्रॉब्लमेटिक सिनेरियो है. And the most simplest algorithm to merge 3 sorted arrays will be what? You merge the 2 arrays first, get a new array of length 2n by 3, then merge this array with the last one. Can I say that? That's the, oh sorry, my bad. So what I'm saying is, you will land up in a situation where you have to merge 3 sorted arrays. How will you merge 3 sorted arrays? The most simplest algorithm will be that you merge these 2 sorted arrays and get a new array of size 2n by 3, and then you merge these 2 arrays and then get a array of size n. Can I say that? Now what will be the time complexity here? Sir, we cannot get one element at last. कैसी बातें कर रहे हो देवाशीष? जब तुम्हारे पास 7 लेंथ की array थी और तुम by 2 कर रहे थे, तो भी तुम्हारे पास सिंगल एलिमेंट आ रहा था ना. मैंने क्या बोला? तुम प्रो मैथमेटिशियन हो. मैं तुम्हें बना रहा हूँ प्रो मैथमेटिशियन, तुम बनना ही नहीं चाह रहे हो यार. प्रो बिल्कुल, मतलब तुम डिफरेंशियल इक्वेशन तो तुम ऐसे सुबह नाश्ते में सॉल्व करते हो, ऐसे लेवल पे हो तुम. तो सोचो. ठीक है, चलो. So now, if let's say you have 3 arrays of size n by 3, what will be the number of iterations to merge these 2 arrays? Can I say it will be order of n by 3 plus n by 3? That will be order of, or not only order of, let's say, how many iterations will be there? n by 3 plus n by 3. That will be 2n by 3. Can I say that? So now you have an array of size 2n by 3 and you want to merge it with an array of size n by 3. Can I say that? So how many more iterations you will need? 2n by 3 iterations you needed to get this array, plus you need 2n by 3 plus n by 3, that is n. Can I say n more iterations? Yes or no? Let me repeat. Listen everybody carefully. You have 3 arrays of size n by 3. First of all, you will merge these 2. what will be the number of iterations to merge the first two arrays? Number of iterations required will be 2n by 3. Can I say that? And the resultant array that you will get will be of size 2n by 3. Can I say that? This is the size of the resultant array. Size of result array. Now you need to pick this array and merge it with this array. You need to do one more merging. The second merging will take how many iterations? Size of this plus size of this. 2n by 3 plus n by 3. That's what? N. So can I say the second merging will take n more iterations? And finally you will get an array of size n. Yes or no? So what is the total number of iterations? Total iterations are 2n by 3 plus n. This is 5n by 3. Can I say that? Can I say that? When you were dividing your arrays into two parts, n by 2 and n by 2, n by 2 and n by 2, the total number of iterations you were taking were n. When you are dividing your array into three parts, the total number of iterations for merging becomes 5n by 3. And 5n by 3 is greater than n. Can I say that? Amit is saying 5 by 3 is constant. Yes. And we can avoid it. But if you see actual terms, when you see actual terms, then it is indeed taking more iterations, right? It is indeed take, like, of course, when you will implement, you will not realize much of a difference. You will not realize much of a difference. 5 by 3 is a very small factor. But the factor exists, right? The factor does exist. So when you actually see mathematically, 5n by 3 is more number of iteration. That means on every level, you will be doing more work. Can I say that? And when at every level you are doing more work, you are aggregating more work. You are aggregating more iterations that you cannot avoid. Are you guys able to get this point? So at every level, can you see? Here, instead of n, you will start doing 5n by 3. Right? Then here what will happen? You will be having 3 arrays, each of size n by 3, right? To make each array, then you have to calculate a similar factor, which will be added, which will be added, which will be added. Eventually, the actual number of iterations that you do will be far more if you divide it into 3 parts. And think about it. If you divide it into 4 parts, it will be even more. 5 parts, even more, and so on. So later, like after a bunch of classes, we will learn an algorithm called as merge k-sorted arrays. Where if you have to merge k-sorted arrays, how can you do it? Right? So don't think that managing 2 sorted arrays was easy and 3 sorted arrays were difficult or 5 sorted arrays were difficult. There exists an algorithm called as merge k-sorted arrays, which we will be learning later. So difficulty to achieve the algorithm is not the case. The problem is the increased time complexity by a factor of 5n by 3. Are you able to get this point? That's why there are other algorithms as well that will always consider a factor of 2. Because in most of the algorithms, the moment you start considering the factor more than 2, the number of comparisons, the number of iterations, the overall actual number of mathematical iterations that it will do shoots up. Are you guys able to get this point? Drop a quick yes or no in the chat.